Welcome to Ask and Learn.
All right, guys, we're going to be doing problem number 70 in chapter 5 of Chemistry Essential Science. So we're going to be looking at these four compounds right here: hydrogen peroxide, calcium carbonate, POCl3, and C2H5OH. We're going to write the balanced equation for the formation of these compounds, and then we're going to look up the delta H value. So let's start with hydrogen peroxide. Right. So that's going to be H2 plus O2 yields H2O2. So we have two H's on the left, two H's on the right, two O's on the left, two O's on the right. Right. So that means our equation is balanced. And if you look at Appendix C, you can find the delta H of formation of these compounds, and that is going to be negative 136x.1 and 0 kilojoules per kilojoules. Now let's look at calcium carbonate. So we're going to add calcium. We're going to add our carbon. And now we're going to add the oxygen. Now, this will produce our carbonate. Now, let's see what we have here. We have one calcium on the left, one calcium on the right, one carbon on the left, one carbon on the right, and we have two oxygens left, but three on the right. So remember when we're talking about the standard enthalpy of formation, we're actually producing 1 mole of our product. So so we have to create a scenario we're only producing 1 mole of calcium carbonate. So instead of having define an integer coefficient, we're going to be using a fraction. So we're going to be using 3/2 of oxygen. So you break up O2 in half. You have an individual oxygen atom. You multiply that by 3. That gives you 3 oxygen, which we use for our carbonate. Now we're going to go to POCl3. Before we do that, let me just write down the standard enthalpy of formation for calcium carbonate: 1207.1 kilojoules. Cl2 gas yields POCl3 liquid. So we have one phosphorus on the left, one on the right, one oxygen on the left. Two oxygens on the left, one on the right. So we have to make this 1/2. And we have two chlorines on the left, 3 on the right. So we're going to make this into 3/2. And we go to Appendix C, we can see that delta H formation for POCl3 is minus 597.0 kilojoules. Also, be very aware that the standard enthalpy formation depends on the phase. So you may find some samples that are both. You can find the enthalpy formation for the liquid phase and also the solid phase, but remember these are two very different things. And now we're going to look at C2H5OH. So we're going to have carbon plus hydrogen Yes. And remember, when we're talking about the formation of a compound, we're talking about its formation from the individual elements in their standard state. And the enthalpy formation of individual elements in their standard state is always going to be 0 kilojoules. Cool. So the delta H of oxygen is going to be 0. However, the delta H of, let's say, an individual oxygen atom, that is not going to be 0. Similarly, the delta H of solid calcium, that's going to be 0, but let's say liquid calcium, that's not going to be 0. So here we have one carbon on the left, 2 on the right, so we added 2 in front of here. 2 oxygens on the left, 5 on the right, so we're going to have 5 over 2. My apologies. We have 5 and 6, so we're going to add a 3 here. We have O2, which we have 2 on the left, 1 on the right, so we're going to add 1/2. And the delta H for ethanol, that is negative 277.7 kilojoules. And that's how you solve these kind of problems. Remember, when we're creating a molecule, we're creating it from its atoms in their standard state. And we also to remember to look up the correct delta H values, which you can find in Appendix C, but also be wary of the phase you're using because that is going to affect their delta, the values that you're using.